Welcome to Geometry 1.3, representing and describing the transformations. We're going to be describing and representing several transformations that occur between points, coordinate points, and at times the images. We're also going to be applying some rules. This lesson serves for chapter 2. It's just an introduction. Okay, so first of all, a transformation changes the position, the shape, or size of a figure. Okay, in rigid motion, the length and the measure stay the same. So that's when we're talking about translation, reflection, and rotation. Okay, as stated there. Non-rigid motion does not preserve length and angle measure. That's in dilation, stretch, or compression. So if the triangle or whatever it is becomes bigger or smaller in size, then it's called non-rigid motion. Important information: pre-image is called the original, image is called the output. Okay, basically whenever you apply a rule is just a rule is instructions for you to do to your coordinate points that will produce another point. Okay, it can be add or subtract, it can be multiplication, it simply can be moving the numbers in the opposite position. So we'll do some examples. Let's start with the first one. Find the unknown coordinates for this transformation and draw the image, then complete the description. Okay, so this is basically what this lesson is about. We're gonna apply this rule. We have points here on the left side, which are the pre-image or the original, and then we're gonna do the rule of x minus 4 or y minus 3. Okay, now the rule is very important because that's how we're gonna find the next point. So x minus 4 is just the x value of the point minus 4. So here's a description. The x value on A is 0, so 0 minus 4 is negative 4, and we have it here on the right. The y value on the A is 4. 4 minus 3, positive 1. So there we have it. Okay. Now next we have the B. 3 minus 4 is negative 1. 0 minus 3, negative 3. Next, 0 minus 4, negative 4, and 0 minus negative 3. We're going to plot these points briefly. First, the original one. The original is 0, 4, 3, 0, and 0, 0. Okay, so we're going to plot this, and that's my original. Now I'm going to plot the new point. Okay, the new point. Negative 4, 1, negative 1, negative 3, and negative 4, negative 3. Okay, that's my new one. So what happened here? What happened? This is called a translation. The figure just slided left, right, up, down. So let's see what happened. My rule tells me what happened. Minus 4 on the x means left. If it would have been plus, it would have been right. So the transformation is 4 units to the left. Then 3 units. On the y value, it's up and down. So minus is down. If it would have been plus, it would have been up. So that's my transformation. 4 units left, 3 units down. A comparison of the image and the pre-image show that both images are congruent. Okay. Moving on. So now we have another rule. We're going to apply that rule. We have our original points. This rule just means it says negative x comma y. The negative that we have here means opposite. Opposite sign of whatever it was there before. Not that your x will be negative. It's just going to be the opposite of whatever your number was. If you look at the point on the left, point R is negative 4, 3. So we're going to do the opposite of negative 4, which is positive 4. And if you want more detail, then you have the description in the middle here, and see what happens, okay? But just a shortcut is just the opposite. It's just the opposite. So this is negative, positive. Negative 4, positive 4. It's simple. Let's graph the image. I'm gonna graph the pre-image first. Negative 4, 3. Negative 1, 3. And negative 4, positive 1. That's kind of what we get. Okay, that's our triangle. And then we're gonna plot the new points. 4, 3, 1, 3, and 4, 1. Sorry about that. Let me erase that. You there? Okay, so here we have a transformation. What happened, which is by observation, we know that from here to here there was a flip, okay, across the y-axis. It's obvious that it flipped. Okay, so whenever you have a negative somewhere in any letter, then for sure it's gonna be reflection. If the negative is affecting x, it's a reflection across the y-axis, and if it's affecting y, it's a reflection across the x-axis. Of course, when you plot them, you get a better picture. The transformation is a reflection across the y-axis, the bottom here. A comparison, I'm just going to put congruent. Both images are congruent. You can also state that there was a reflection, but we already stated that in the previous sentence. Moving on to the next example. Here we have another kind of rule. Now we have a number in front of the letter. Well, we're going to multiply whatever x is. You don't have points, so I'm going to go ahead and write them. Negative 1. Let's do 2, negative 3. Okay, so we have these points, and the rule states 2x comma y. My y's are not going to change, so I'm just write those down. 2, negative 1, and negative 3. However, my x are being multiplied. Okay, they're being multiplied by 2. So 1 times 2 is 2. 2 times 2 is 4. And 2 times 2 is 4. Okay, so once we plot them, we're going to see that this is a dilation. Okay, I don't want to get into detail with dilations yet, but it's either going to be enlargement or shrink. But next week we're going to get into detail. Okay, so let me see if I can plot them. 1, 2, 2, negative 1, and 2, negative 3. Okay, so we're going to have something to really compress triangle, then enlarge into 2, 2, for negative 1, and for negative 3. Okay, so yes, it became bigger. Okay, it was a dilation. Okay, don't worry too much about this yet. Next week we'll be covering that into detail. Okay, and don't worry about this either. Okay, any questions you have, please ask me in class or after class, after school, before school. Okay, do not stay with any doubts, please. Thank you. See you on 1.4.